Alright, so I have the problem 7 to the power of 100 minus 7 to the power of 97. So I want to calculate this problem without a calculator. So to solve this, I'm going to first rewrite 7 to the power of 100 as 7 to the power of 97 plus 3. So now I have 7 to the power of 97 plus 3 minus 7 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 7 to the power of 97 plus 3, that's going to equal 7 to the power of 97 times 7 to the power of 3. Then I have minus 7 to the power of 97. Now from here, if I factor out 7 to the power of 97, 7 to the power of 97 times 7 to the power of 97 times 7 to the power of 3 divided by 7 to the power of 97, simply just 7 to the power of 3 minus 7 to the power of 97 divided by 7 to the power of 97 is 1. So now this is the same thing as 7 to the power of 97 times 7 to the power of 3, that's equal to 343. So times 343 minus 1. Now 343 minus 1, that's 342. So my answer is 342 times 7 to the power of 97. Now, second method to solving this problem. So I first start with 7 to the power of 100 minus 7 to the power of 97. So before, we replaced 100 with 97 plus 3. But now we're going to replace 97 with 100 minus 3. So now I have 7 to the power of 100 minus 7 to the power of 100 minus 3. So now I'm going to rewrite 100 minus 3 as 100 plus negative 3. Now remember, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 100 plus negative 3, that's going to equal 7 to the power of 100 times 7 to the power of negative 3. Now, if I factor out 7 to the power of 100 from here, I have 7 to the power of 100 times 7 to the power of 100 divided by 7 to the power of 100 is 1, minus 7 to the power of 100 divided by 7 to the power of 100 times 7 to the power of negative 3 is 7 to the power of negative 3. Now, 7 to the power of negative 3, 1 minus 7 to the power of negative 3. Well, 7 to the power of negative 3 is the same thing as 1 over 7 to the power of positive 3. And 7 to the power of positive 3 is 343. So now I have 7 to the power of 100 times 1 minus 1 over 343. Now 1 minus 1 over 343, we could go ahead and do that over here. 1 times 343 is 343. Now 1 times 343 is 343 again, minus 1 times 1 is 1. So I have 342 over 343. So I have 7 to the power of 100 times 342 over 343. So this is another solution. Alright, so in this problem I have 2 to the power of 19 minus 2 to the power of 18. So for my solution, first start with 2 to the power of 19 minus 2 to the power of 18. Now 2 to the power of 19, this is the same thing as 2 to the power of 18 plus 1. So now I have 2 to the power of 18 plus 1 minus 2 to the power of 18. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1, that's going to equal 2 to the power of 18 times 2 to the power of 1. And I have minus 2 to the power of 18 at the end. Now from here, I can go ahead and factor out 2 to the power of 18. So I have 2 to the power of 18 times 2 to the power of 1 minus 1. Now 2 to the power of 1, that's simply equal to 2. So I have 2 to the power of 18 times 2 minus 1. And 2 minus 1, that's equal to 1. So now I have 2 to the power of 18 times 1. Now 2 to the power of 18 times 1 is simply just 2 to the power of 18. So I'm simply left with 2 to the power of 18. Now, although this is a solution, I'm actually going to find a way to simplify this. So 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2. And if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 9 times 2, that's going to be 2 to the power of 9 to the power of 2. Now 2 to the power of 9, this is equal to 512, so I have 512 to the power of 2. 512, I'm going to rewrite this as 500 plus 12 to the power of 2. Now this is the same thing as 500 plus 12 times 500 plus 12. So to solve this, I'm going to first start by distributing the 500. So now I have 500 times 500 plus 12 times 500. Now if I distribute the 12, I have plus 12 times 500 plus 12 times 12. Now 500 times 500, that's going to be 250,000. Plus 12 times 500, that's going to be 6,000. Plus again 6,000. Plus 144. Now 6,000 plus 6,000 is 12,000. And 12,000 plus 250,000 is 262,000. Plus 144 is 262,144. So this is my answer. Alright guys, so in this equation, I have 2 to the power of m minus 2 to the power of n is equal to 8,064. So I want to find the value of m and n. So, because 2 to the power of m minus 2 to the power of n, because this is positive, we know that 2 to the power of m is greater than 2 to the power of n, meaning that m is greater than n, because both of these are the same bases. So I'm going to let m equal to n plus k, and k is an integer. So if m equals n plus k, then I have 2 to the power of n plus k minus 2 to the power of n is equal to 8,064. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k, that's going to equal 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 8,064. Now if I factor out 2 to the power of n, I get 2 to the power of n times 2 to the power of k minus 1 is equal to 8,064. And 8,064, this is simply equal to 128 times 63. So I have 2 to the power of n times 2 to the power of k minus 1 is equal to 128 times 63. Now notice I have 2 to the power of n, that's going to be an even number, and 2 to the power of k minus 1, that's going to be an odd number, because 2 to the power of k is going to be even, and an even number minus 1 is going to be odd. And 128, this is even, and 63, this is odd. So now, meaning I can simply set the evens equal to each other, and I can set the odds equal to each other. So 2 to the power of n, this is equal to 128. So let's first go ahead and solve this. If 2 to the power of n is equal to 128, well 128, that's the same thing as 2 to the power of 7. So I have 2 to the power of n equal to the power of 7, and this means that n is equal to 7. Now, we have 2 to the power of k minus 1 equals 63. So if 2 to the power of k minus 1, if 2 to the power of k minus 1 is equal to 63, then all I have to do is simply add 1 on both sides. These two cancel out, and I'm left with 2 to the power of k is equal to 64. Now 64, that's the same thing as 2 to the power of 6. So if 2 to the power of k is equal to 2 to the power of 6, meaning k is equal to 6. So now remember how we said m is equal to n plus k. So in this case, n is 7 and k is 6, so m is equal to 6 plus 7, which is 13. So m is equal to 13, and n is equal to 7. So these are my solutions. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared. So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now, what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now, I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now, by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end.